Any good movies this weekend? No good movies. All right. Well, I guess we got to start math now.
But we have to stall.
No, I've tried. I tried talking, and y'all just don't want to talk. So.
No, we just have a few questions.
No, I don't ever watch Clemson games.
Why?
Because they play nobody. That's why I watched Maryland versus Ohio State. That was the only game worth watching this weekend. And it wasn't worth watching until after the second half when they were actually had a chance to win.
Did you watch UCF Cincinnati?
No, I didn't get to. Who finally won?
UCF won by like 30.
They won't give them credit though. It amazes me how they ignore UCF.
Yeah.
They just ignore them.
Are they still undefeated?
You know they claim themselves national champions.
Well, I don't think you can do that.
They have an empty trophy case.
Yeah. I don't think you can do that.
I want to be Corbin.
So hard to know. But it would be kind of like 80s. You could be baseball or we're all paid. I feel like now we'll actually start it. Because it'd be really sad if I missed my last.
Who do we play with?
Dorman.
In the
Yeah. I mean, all of them from now on are supposed to be good. Yeah.
I know it.
We're just too good. Can I say? Oh, that's really cute. It looks like something my mother would wear. But my mother wears really cute clothes.
So really?
So really? Sales.
All right. Y'all got to get your notebooks out now. We got to actually do this. Because it's Monday. And if I have a free day on Monday, right before Thanksgiving, somebody will bitch. So.
I'm gonna forget everything on that.
Me too.
I'm gonna email
So much out of my book. See, but the way I look at it, I'm gonna get another paycheck in like 2 weeks.
So basically.
Marker, any color.
I got you. See, I'm just already embarrassed.
Jacob does.
I know someone who's not thinking about who's here right now.
Oh.
It's stuck on DSC date.
Oh no. I feel like that'd be even more annoying because I swear every time somebody at work asks their date, their check, and they ask me what day it is, and I'm like, I got you the 19th.
Right now, my school is the day the 18th. I'm like, I know that's not much better. I think I got picked.
There she is.
Okay. Y'all ready? Well, I'm sorry. We can't do that. Just right before the break. If I do anything before the break, it's condemned. So I can do it like next week or a week before the break. If I do it the week of the break, I'm concerned. I'll get an email that says, I'm concerned. A student called and said that you did this during the class. So, what's the rule?
There's always one.
Exactly.
Who's the one?
They're not going to advertise and put a sign over their head and say, "I'm the one."
Yeah, they're probably not here today.
I guarantee you, nobody's listening, so I'll just be quiet. I guarantee you, somebody knows what goes on in this class before this class is over every single day. How much you want to bet?
The security guard that walked in.
No, I'm talking about people texting their parents or whatever. Well, I'm not worried about your dad or your mom because your dad will take care of me. I hope he'll take up for me. All right. So, sampling distributions. This is the last unit. So, you're responsible for everything we cover until the last day of class. So, if we cover till 8.2, then the last test will cover 8.1 and 8.2. Does everybody understand that? Okay, if we get to 9.1, then you're responsible for everyone. Do not ask me the last day of class, what's going to be on the test? Because then I'm going to look at you like you're an idiot. Okay? I've just told you twice, whatever we cover until the last day of class. When is the last day of class?
December 3rd.
Wow, Monday, December 3rd. Thank you. Okay? So, everybody got that? Somebody will walk up to me after class on Monday, December 3rd and say, what's going to be on the test? Wait and see what I tell you.
As long as you let me know when you're reopening the homework.
Nah, don't let anybody know. I just let y'all find out. Okay.
Okay, so y'all know my number.
All right. I'm going to write these two things down. I'm just ad lib. The sampling distribution of a statistic, meaning lowercase statistic, meaning a variable in the sample, okay, is probability distribution for all possible values of the statistic computed from the sample size n. Make sure you circle the word all, okay? The sampling distribution of a statistic is a probability distribution for all. That's one of your questions on your homework. Sampling distribution of the sample mean x bar is the probability of distribution of all possible values of the random. There's that word all again. Okay, random variable x sample size n from a population with mu and standard deviation sigma. Now, what we're going to be doing basically is comparing means, mu and x bar. Okay, what is x bar? The sample mean. What is mu? It says it right there, population mean. Okay. And the question in the homework or the test question will ask something to the effect of the means, and the word all is the only thing you need to remember. We are going to be basically taking a sample, if we make it, which we won't, to the end of Unit 4. You take a sample mean, and based on the confidence level or the confidence interval, you're saying, okay, this sample mean tells us that the population mean is going to be this. And that way you can say, okay, I'm 95% confident, or I'm 99% confident, because 100 represents what? Perfection. And, perfection walks on water, and I don't think any of us can do that. So we'll just leave it 99%. Now, a confidence interval, a confidence level in this book or in this class will be 90 to 99%. Why would you not use below 90% with a confidence level? Do you want to walk into a meeting of Michelin executives or blah, blah, blah executives and say, I'm about 75% confident that this data is correct? No, you're fired. Okay? Especially when your numbers for this presentation is going to go on next year's budget. Okay, if you walk in there with a 75% confidence level, they're going to probably say, I'm concerned. Whenever you hear, I'm concerned, that's not good. Okay? Take it from somebody who knows. All right? I'm concerned. All right. Also, now, will you see a 75% confidence level in your homework? Yes, because they're just regenerating numbers. Okay? But usually, if you're presenting or if you are viewing something that's being presented, and they say, I've got this at a 92% confidence level, that means they're pretty sure. Okay? How many of you have seen movies or TV shows where they match up a voice on a recording to the voice of the killer, and they say, oh, that's about a 98% confidence level, or a 98% probability, or something like that. They're sure. Okay? So what are we doing? We're comparing the sample mean or the sample standard deviation and saying that the population will be this, and I'm 98% sure, or I'm 92% sure. Okay? Now this first section is going to be pretty simple. This is calm before the what? The storm, because then you get the null hypothesis and the alternative hypothesis, and that's when it gets kind of queasy. Okay? It gets kind of confusing. But you got to go into the confidence level and the null hypothesis and the hypothesis with the complement way of thinking. Okay? If something is even, then what's everything else? Not even. Okay? What's the opposite of guilty? Not guilty. What's the opposite of true? Not true. You can't say just false. You got to say not true, because sometimes there's gray areas, right? If your data falls in a gray area, that means it's not this. You can't say it's false because it may be in that gray area between true and false, and you can't say true or false. You have to say not false. Okay? Capiche? All right, I'm getting ahead of myself. I'm sorry. Okay, write this down. Step 1. Obtain a sample size n. So what they're saying is you're going to do a sample and you're going to do the Anderson campus. You're going to survey all the people at Anderson campus that you can, and you're going to predict the outcome for Tri-County Technical College. Okay, because Tri-County Tech don't want to spend the time or the money to do all of their students. So what they do is they're going to go to the Anderson campus. Now, is the Anderson campus the same demographics as the Pendleton campus? Hail to the no. Okay? You got all sides. You got your rednecks, you got your bubbas, and then you got your people that think they're rich, and then you got your people that are rich, which you don't know it. Okay? And then you got your people that don't care. And then you got people that are not from around here. And then you got people that are this. So, what's the difference? All right? Well, that's where the confidence level comes in. Okay? That's where I got to figure out if this average is going to represent Tri-County Technical College. And that's where you have to go through and do the math. Okay? So, everything that we've been doing up till now is going to go into this last unit. Okay? So obtain a size. And it's going to and they're going to give you a formula to where you actually have to figure the sample size in order to be a certain confidence level. Remember me telling you about the Michelin guy that only did 10 tires? Well, we're going to do a formula here, and it's going to say, okay, if you want this confidence interval, you need to pull 10,000 tires because this formula says so. If you want a 92% confidence level, then you have to pull 900 tires or whatever the case may be. Capiche? Compute the sample mean. And I'm just writing these. This is I would write them all down at one time, but the slide evidently don't think you can handle that, so they just put it on one page. course, some of y'all invented this unit, so, right? I would say this is probably the most difficult unit of all the units for those that invented it. Assuming that we are sampling from a finite population, repeat steps 1 and 2 until all distinct random samples of size have been obtained. That's really kind of redundant, but it'll make sense once we start doing the margin of error formula, once we start doing the confidence interval, and once we start doing the sample size. Once we start computing those, then you'll start saying, okay, this is the first step. Now again, nobody is going to expect when you walk out of this classroom for you to have mastered statistics. It takes at least 4 or 5 classes for you to actually see what happens with probability and statistics, okay? Except if you invented statistics. The main thing I want you to see is whenever you look at a poll now, or whenever you look at a presentation, whether it be in school or whether it be in business or whatever, and you see a margin of error, you see a confidence level or a confidence interval, you know that they are predicting all of this based on all the stuff we went over, statistics and probability. That's what you need to see out of this class. Okay, now this is, you don't have to write this down. This is just I'm going to go very slow here because the weights of pennies minted after 1982 are approximately normally distributed with a mean of 2.46 grams and a standard deviation of 0.02. So at this point, when you're reading this question, the first thing you should do is draw a picture. All right, draw the normal distribution with 2.46. Then the next one will be 2.48. The next one will be 2.50. 2 standard deviations to the left, 2.44, 2.42. Okay? So 90%, 95% of your pennies are going to fall between 2.42 and 2.50 grams. All right? Of course, you do have some pennies that are stamped together, and they're rare. There's actually one penny, my sister, she collects wheat pennies. And there is a penny, a 1943 wheat penny, that is made out of stainless steel because they wasn't using copper because of the war. You know, World War II. Forget it. Anyway, that penny is worth $80,000. Can you imagine finding 2 or 3? $80,000. That's what it goes for if you find one. A 1943 wheat penny, and it has to be the stainless steel. I don't know how you tell. I guess you take some varnish or whatever you call that stuff and clean it up and see if it's stainless steel or if it's copper. My sister has like a shoebox full of wheat pennies. And I told her, I said, you need to go through those wheat pennies. Oh, well, one day. So, approximate the sampling distribution of the sample mean by obtaining 200 simple random sample size. N is equal to 5 from this population. All right, there they give you N. N is equal to 5. A size, okay. So they want you to do, and you'll see it next, put 200 groups. Okay, there's the first one. So 200 of these. Okay, so you're talking about there's 1, and then 2, and then 3 up to 200. So 200 groups. Okay. That's the difference between a simple random and a random sample. Random sample is just one individual. A simple random sample is a group. So simple random samples, 200, that's 200 little groups. Okay? All right, so X mean for this one is 2.4. Now, they're going to have 200 means, okay, because there's 200 groups. So they're not going to show it, of course. They're just going to show a lot of them, okay? And there they are. So they get a bunch of samples. Remember me telling you about the MIT students took a roll of quarters and they measured all of them. They weighed them, they scanned them with the infrared scanner to reproduce them in a virtual world, and they took a micrometer and they did all 10 of them. It was like 40 of them in a roll of quarters. They did all 40 of them, and they came up with 1 quarter. Does everybody remember me telling you about that? And then they flipped it, they wrote an algorithm, and then they flipped it into and it took 100,000 flips for it to reach 0.5 probability. Remember me telling you that? Large number rule? Okay, well, they're doing the same thing here with each of those groups. They're finding the average of each of those groups. Okay? What basically it means, what we're saying is that when you're doing the confidence interval and you get your N, all right, you get your N and you get your, your mean, that you need to make sure you follow the large number rule and you don't just half-ass do it, okay? When you're talking about presentations, you're talking about keeping your job, there's two rules. Cover your rear end and don't half-ass do it, okay? And that's what they're showing. Make sure you cover your back end and make sure you do lots of numbers, okay? There's more, okay? I don't know how many's on each, but anyway. The mean of the 200 sample means, in other words, the mean of all those means is equal to 2.46, the same as the population, okay? The standard deviation of the mean is 0.0086, which is smaller than the standard deviation of the population. The next slide shows the histogram, or the bar chart, okay? So there's the weights. What does it look like? That's not rhetorical. I'm asking somebody to interact with me. What does it look like? The bell curve, the normal distribution. I know, this is exciting stuff. I know. What role does N, the sample size, play in standard deviation and sample mean? As the size, here it is. Here's the question. Write that down. As the size of the sample increases, the standard deviation of the distribution of the sample mean decreases. Well, that's the large number rule. Remember, the large number rule says the more that you use, the closer the probability, the theoretical probability, the physical probability is to the theoretical probability, right? So what would happen to the standard deviation if you just kept crunching numbers? It would get smaller and smaller and smaller because you're using more what? Numbers. It's kind of redundant, I know. The size of the sample. As the size of the sample increases, large number rule, the standard deviation of the distribution of the sample mean decreases. The more numbers you use that are close together, the less outliers you have and less unusuals you have. So therefore, the standard deviation starts to what? Starts to get smaller. That's what that means. Approximate the sampling distribution of the blah, blah, blah. And this time, do 200 groups, but the sample size has increased to what? 20. So what you're going to see here is you're going to see that the standard deviation is going to get smaller than it actually was with 5. It's going to get smaller, basically. And there it is right there. They just did it. There we go. Okay, this is our first, the mean and standard deviation of the sampling distribution. Write that down, okay? Because what's going to happen is your standard deviation is going to change. Remember how we did x minus x bar over standard deviation? Now it's going to be x minus x bar over the standard deviation divided by the square root of n. Okay? So it's going to be a little bit different. No sneezing in class. Sorry. Everybody got that formula written down?
Is that all we need?
You can actually, what?
Is that all we need?
Yeah, just the formula. Basically, this is a more detailed standard deviation. That's basically what it is. I wish they would get to an example instead of all this stuff. Okay, here we go. This is the first example. So, weight of pennies, minute after activated, blah, 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 blah. Okay? What is the probability that in a simple random sample of 10 pennies minute after, okay, 10, there's your new N right there, okay, we obtain a sample mean of at least 2.465 grams, okay? Write that second paragraph down. You can write both of them down, okay? This is a good example because it could be a test question. I'm sorry, I found my old watch, what's called a Gear 2S or whatever it's called. I found it. It was in the coffee table. I thought I'd lost it, and it was in my coffee table. Anyway, make a long story short, I decided to start using it now that I've only used it one time since I've had it, and then I thought I lost it. So that happens a lot, especially when you have a 10 or 12-year-old. They think everything that's yours is theirs. So I think I had a little help in losing it. What is that pink blob on your keychain? Oh, that's nice. I like that. Where did you get that?
Online.
That's
My mom makes
nice.
Me and my sister keep them on our keys.
Good. I'm gonna get my daughter one.
They have different colors too. Oh yeah. It sounds like it is a weapon.
Whoever came up with that is very
You
smart.
can get it through airport security, and you can take it on college campuses.
That's good. That's really neat.
Here.
Good. All right. So here is what you do. There it is. So you take x minus x bar over the standard deviation. And in this type, it's not the standard deviation. It's the standard deviation over the square root of 10. Okay? I don't like writing it the way they do. Okay? So x minus x bar. And they ask you x right here. See the 2.4 says we obtain a sample mean of at least 2.465. So that's your x. So what I tell students, and most books write it like this, but for some reason your book doesn't. Your z-score that you learned way back, your z-score you learned way back was x minus x bar over standard deviation. Remember? Okay. Now that you're smart and you know all this stuff, now we're going to make it more detailed and we're going to zero it in a little bit more, make it a little bit tighter. And we're going to go z is equal to x minus x bar divided by the standard deviation divided by the square root of what? N. In this section, this is your new z-score when it says at least, or when they ask for a newer z-score. It's a whole lot, it makes a whole lot better sense when you look at the formula like that, because what happens when you put a fraction in a fraction, in the denominator of a fraction, the number gets bigger. Okay? Yeah, it does. When you put a fraction, a proper fraction in the denominator, you're dividing by a smaller number. So if you divide by a smaller number, your product gets what? Bigger. Your answer gets bigger. That's all right. Just take my word for it. So there is your z-score. And then what do you do with that z-score? You look it up in your what? Table, or you do 2.465 to what? infinity. 9999. So that's a good example to have. And make sure you write down, and I just want to go back here, right here, 10, right there. That's an indicator. Highlight that 10 and highlight at least. That's your X. So this is your N. Don't judge me. I'm writing with a mouse. And this is your what? Your X. And you've got X bar right here. And you got your standard deviation right here. So you got X bar here. And you got your standard deviation right there. So if I give you one of these questions, you should be able to plug and what? Plug and chug. Now the only thing is you need to write down at the end, right here, you need to make sure you know what to do with it. After you get it, you got to go to second bars, what is it? Normal CDF or PDF, and go 2.465 to what? 9999. Because it's asking for at least. What about at most? Then it'd be from negative infinity to 2.465. So you got to be able to read the question. Now these are 2 or 3 questions on your test that are very simple. I don't want you to miss them for the 80% of you that get it right. Okay, here the following table histogram gives probability of rolling a fair die. Okay, estimate the sampling distribution by obtaining 200 random samples sized in 4. Okay, there's n. And calculating the sample mean for each of the 200. Repeat for n is equal to 10 and 30. So go back. Let's see what they give us. What do they give us? Well, down there, 3.5, and standard deviation is what? 1.708. Okay, so now they're giving you mu, so it'd be x minus mu over standard deviation over square root of what? The square root of, bless you, the square root of 4, the square root of 10, and the square root of 30. You got to do 3 separate formulas.
What was the first one?
I'm sorry, what?
The first one? You said 30 first.
Right there? Oh. N is 4,
Okay.
N is 10, and N is 30. So you're going to have to put those 3 in the denominator. And they didn't do the calculations, but there it is. N is equal to 4, N is equal to 10, and N is equal to 30. It's not a test question. I'm not going to ask that, but I'm just telling you that that's what you're going to type in. Okay. I've already gave you that. I don't need to give you that again. Write down the second one. The shape of the distribution of the sample mean becomes approximately normal as the sample size what? And what can you attribute that to? The blank blank rule.
Large number.
Thank you. You put it together. Good job. Whoa. Ain't that what Patrick does in the orb of confusion? Oh. So you just need to write down the shape of the distribution comes more to shape as the number of n increases. Regardless of the shape of the underlying population. You don't really need that, but go ahead and write it down because some of y'all are OCD. Regardless of the shape of the underlying population. Who is Rector?
Ben Rector.
Huh? Oh, I thought it was a political. Oh, I'm sorry. It looks like a political shirt.
I know it's not. Yeah.
I'm gonna
Heard
run
of
for
him.
Congress.
Huh?
I'm gonna run for Congress.
Good job.
What?
You know, all you gotta do is get one term and you're set for the rest of your life. All you gotta do is serve one term and you have benefits and a check for $174,000 the rest of your life. But you gotta find an apartment first. You might not be able to do that because some people running for Congress can't figure out how they're gonna pay for their apartment.
Yeah. Aren't they passing a bill about that still? Or did that get shut down?
I don't know. You know, actually, Congress people went up there part-time when they wasn't working, and they did that back when the United States first started. And after they got through doing what they needed to do, they went back home to work. Well, that's what a concept. That's what happens when greedy people gets in power. They change things to make themselves get richer. Harry Truman said one time, was it Harry Truman, I think, or FDR said that if a politician goes in office and gets rich, they're not a good politician because they're not supposed to get rich. Regardless of the shape of the underlying population, the sample distribution becomes approximately normal as the sample size increases. It's kind of redundant, isn't it? They're just trying to get across to you, if you're going to present, if you're going to do this as a job, make sure you don't half-ass it. But that's pretty much true in any kind. You all right? Okay. I'm not going to do this again because that's another problem. I'm not going to go through it again. It says, suppose that a mean time for an oil change at a 10-minute oil change joint is 11.4 minutes with a standard deviation of 3.2. If a random sample of n is equal to 35, in other words, 35 cars come in, okay, describe the sampling distribution. Blah, 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 blah. So you put the 3.2 over the square root of 35, which comes up to be 0.5409. But that doesn't tell you anything because you need to put it in the formula to actually tell what the standard deviation does. So you're going to be dividing x minus x bar by 50.5409. And that's what they do. 11 minus. So what happened to the standard deviation? Now it's point what? Oh, I'm sorry. The z-score is now 0.23. And what was it before? Did they actually say what it was? No, they didn't. So take x minus x bar. Let's see. X bar is approximately normal distributed with a mean of 11.4. Well, they're just finding the z-score. Okay, that's fine. Okay, here's where we actually get into the last unit. Here we go. Write that down. That is called p-hat.
P-hat?
P-hat.
P with a hat?
Yeah, like the thing
Yeah,
says
I know
p-hat
that.
right there. Okay? Not fat, but p-hat. Now, with p, there's always a complement to p, right? It's called q. There's going to be a q hat also. So go ahead and write down p hat is p hat, and q hat is the complement of p hat. Y'all like the word p, or is that what's so funny? That's called a caret symbol. It's not a hat. Caret, K-A-R-E-T, caret. Please don't call it a little house top or a little hat, okay? That will show your ignorance if you walk into a room. Oh, that's P hat. That's got a little hat on it.
Why is it not P carrot?
Huh?
Yeah, why is it not P carrot?
I guess because we're too stupid. We as students are too stupid to,
They call it P hat because there's a hat on hat.
Okay, it's P beret, okay? It's a beret. All right. Now, I want you to underline that word. Sample what? Okay, there's that P word again. What is P representing? Proportion, percentage, probability, area. Write that down. That could be representing 4 different things. So the question may say, well, you have a probability of 0.222. Well, you don't have to figure the probability because it's already figured for you. But if they give you a proportion, they're going to say like 17 people in here. 17 out of 30. 17 out of 30, that is a proportion. That would be P hat. Now, it's very important that you understand that because the question is going to start off with saying there's 250 employees at this workplace and 100 are sick. What is the proportion? What is P hat? Well, you've been doing it ever since the first unit. It's 100 over 250. But when they put P hat in front of it, it confuses a lot of students, okay? It's the same thing you've been doing since the first unit. You put the number that exists over the number of total, N, okay? So write that down and highlight it because you're going to be doing that a lot in the next homework, okay? Now, if P hat is the actual proportion, then Q hat is its complement. So if 100 got sick, how many are not sick? Not sick would be 150. Not sick, does that mean hungover? Does that mean overslept? Does that mean, you see, not sick means a lot of different things. So you can't say sick and healthy or sick and feels good because you can have a hangover and you're not feeling good. You can, you could overslept. You ever overslept and end up coming into a meeting or a class and you feel like crap because you just woke up 5 minutes ago? All right, or 15 minutes, whatever the case may be. All right. In other words, all of us are creatures of habit. You get up, you follow the same routine every morning, okay, or you will. All right. If you get out of that routine, it messes up your day just as much as having a stomach ache. But you can't call it sick because you're not technically what? Sick. And that's a lot of probability and statistics about the verbiage, about the definitions, just like accounting. A lot of people fail accounting not because of the math. The math is adding and subtracting. Why do they fail accounting? Because of the terminology. They don't know when to add or subtract because they didn't learn the vocabulary words in the first unit. Okay? So, P hat and Q hat. Q hat is the complement to P hat. And the reason I spent so much time on that is because every one of your questions from here on out is going to ask for that. Okay? And write down this equation, or you don't have to write the whole thing down. Okay, just write down the main parts. Quinnipiac, whatever. What is Quinnipiac? Well, if you ever watch the news, real news, not fake news, but if you ever watch real news, okay, meaning that all they do is report the news, okay, then they're gonna talk about Quinnipiac. Okay, it's a polling service. Okay, it's just like all the other ones. There's a bunch of them. Okay, Rasmussen. How many of you ever heard of Rasmussen? Some of you haven't. All of you haven't. No. Okay. Rasmussen is one of the polling agencies. Quinnipiac is another one. They do a lot of polls. That's what they base their whole existence on, is polls. All right, and conducted a poll 2008. 1,745 registered voters were asking whether they approved of the way Bush handled the economy. 349 said yes. Then the rest of them said what? Not yes. Because some of them could have said what?
Not answered.
Exactly. Some of them could have said other. Or some of them could have said, I don't want to answer that. Or some of them could have said no. Or some of them could have said, he's a son of a bitch. Okay? They didn't answer yes or no. So you can't say, okay, these answered yes, these answered no. You can't do that. Okay? You got to say yes and not yes. Okay? Obtain a point, and there is your p hat. So what is your q hat? Whatever 1745 minus 349 is. Somebody do that right quick so you can write it down, so you can highlight it, so you can memorize it. Somebody take 13 or 349 away from 1745.
1396.
1396. So 1396 over 1745, or 0.8, is going to be your q hat. Now, there are formulas where you use p hat and q hat together. So make sure you make a note of that. According to a time poll here, 42%. Okay, 42%. Is that a proportion? No, it's not a fraction. But they already have done the math for you, and now it's a percentage. It's still p but it's not considered p hat, but you'll use it like p hat because it's a proportion. Okay, anyway, blah, 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 describing the distributed proportion for sample size n is equal to 50, 10, 50, and 100. And they're just showing you what that looks like. I'm not really concerned with that. And shape, center, spread. We talked about spread a long time ago. The standard deviation dictates the spread. If you've got a big standard deviation, that means it spreads out. If you've got a small standard deviation, that means it's what? It's more tight. That means your data is better. What do you want? You want a small standard deviation. You don't want a large standard deviation. We talked about that first unit. Okay? All right, write that one down. Here is your, and that's not 1 minus p. Y'all are smart enough to know that's q hat, okay? For years, it's been called q hat. Now, all of a sudden, I guess books think, well, these students aren't smart enough to realize q hat is the opposite of complement. So we're going to write it as 1 minus p. Anyway, in majority of your books, it's going to be called q hat. P times q hat, p hat, q hat over n, or pq over n. All right? And y'all know this formula from back in chapter 7 or 6, NPQ. Remember NPQ? And then the square root MP, and then NPQ. Well, some of y'all do. And that is standard deviation is equal to PQ over N, square root. Of course, the variance would be that raised to the second power. So that's kind of redundant. And that's the same thing, blah, blah, blah. That's just another example. I want to get to alpha. We'll get there in just a second. That's another standard deviation. They're using MPQ. There's P, there's Q over 50. That's standard deviation. And we'll do enough of these when y'all come back from Thanksgiving. Well, I'm trying to get there, but okay. That's enough for today. I'm going to let y'all leave now that we actually did some math. Y'all can leave. Have a good Thanksgiving. Be careful. Keep between the ditches.